Abhilash, please share the question sharing Google Talk
Yes, sir.
at our admin group. Yeah. Abhilash, am I audible?
Yes, sir.
So after finish the technical session, are you able to give a demonstration for how to do the uh, video Google Doc? Whatever you prepare the video, na, that one are you able to do the demonstrations?
Yes, sir. I will do, sir.
Okay, because many questions we have received from participants, they are getting little confusion. So
Okay, sir.
therefore, if you give a little demo, that will be good for them.
Okay, sir.
And also please check that Rikes groups, whichever I sent, that one I will forward to you. Check all the things.
Okay, sir.
Sir, Chief Guest, sir, can we start the program, sir?
Yes, sir, we can go.
Okay. Nivedita, are you ready?
Yes, sir.
Okay. Very good evening to all. This is Dr. Wasim Alai, coordinator of this 1 month summer internship on recent advances in chemical sciences. So, on behalf of our summer internship family, I welcome our today chief guest, Dr. Jayakumar Kandasamy, Associate Professor, Department of Chemistry, Indian Institute of Technology, PHU Varanasi. First of all, I thank Professor Dr. Kandasamy for his kind acceptance of our invitation with his busy schedule. Now I request Nivedita to deliver a welcome address.
A very good evening to everyone. Jane Goodall once quoted, what you do makes a difference, and you have to decide what kind of difference you want to make." With a beautiful saying, I welcome respected dignitaries, Professor Dr. S. Puttirani, Dean, School of Physical and Chemical Sciences, Professor Dr. D. Ishwaramurthy, Head of the Department of Chemistry, Professor Dr. N. Vasimalai, Coordinator, faculty members, and participants. On behalf of the management of B.S. Abdurrahman Crescent Institute of Science and Technology and everyone, I have great pleasure in this wonderful evening in welcoming our chief guest, Professor Dr. Jayakumar Kandasamy, who has kindly consented to be the speaker of today for the 1 month summer internship program on recent advances in chemical sciences. I heartily welcome you, sir. It's my great privilege to give the chief guest introduction about our most eminent speaker today. Professor Dr. Jayakumar Kandasamy is currently working as an associate professor at Department of Chemistry in Indian Institute of Technology, BHU Varanasi. He received his PhD from IIT Madras. He had done his postdoctoral research in Israel from 2008 to 2011 and also in Germany from 2012 to 2013. Professor Dr. Jayakumar Kandasamy has received various awards and honors. He cleared the GATE entrance exam with 95 percentile in 2004, and he was the topper in comprehensive exam in IIT Madras in 2005. Later, he received the prestigious CSIR, JRF, and SRF. He also received the Coolidge Postdoctoral Fellowship in Israel. In 2011, he has won the prestigious Euroglycoscience Award from European Young Investigator Workshop held in France. His areas of research are carbohydrate synthesis, medicinal chemistry, and reaction methodology of N-nitrosoamines, sulfoxamines, and amide activations. In the past, his research projects had been funded by DST SERB and Indo-Max Planck Partner Group. Currently, his research work has been funded by DBT-sponsored Indo-UK project. He has been guiding several PhD scholars and MTech students. As for today, he has published 51 research articles in various reputed journals and also 2 book chapters. He also holds a patent for one of his research work on preparation of aminoglycosides and uses thereof in treating genetic disorders and as an antibacterial agent. He has been actively giving impressive talks and presentations in various national and international conferences, and also organized 3 international conferences in IIT BHU. Leonardo da Vinci said, "Once you have tasted flight, you will forever walk the earth with your eyes turned skyward. For there you have been, and there you will always long to return." Similarly, ever since our chief guest, Professor Dr. Jayakumar Kandasamy, tasted chemistry, He couldn't get enough of it. He has been dwelling in the beauty of chemistry till today and will forever. I once again welcome you, sir, with a strong belief that our chief guest will create a great impact among participants. I hand over this session to Professor Dr. Jaikumar Kandaswamy.
Yeah, good evening to all of you. So is that I'm audible to all of you?
Yes, sir, you are audible, sir.
Yeah, okay. Okay, nice. So first of all, I would thank Dr. Wasimalai for giving this wonderful opportunity, particularly for interact with master and young PhD scholars. So I was previously thinking to have some topics related to research. Then I thought maybe one of the very interesting topic in organic chemistry is asymmetric synthesis, and maybe some of the MSc students will study second year. And it is very interesting, not just only in the name of textbook. It is also interesting in the name of research and development. I would like to cover few aspects of asymmetric synthesis. That is usually that covers the syllabus of master students. I will try my maximum best to complete at least some part of this asymmetric synthesis. If time is a little bit more needed, then we'll go, or otherwise maybe I will try to have another one class maybe next week sometime. So I wish that all of you should interact with me during the class. If you are having any doubts or something, you can stop me and you can ask me. We can go ahead after that. Or if you are willing to ask the question at the end of the presentation, that is also not a problem. That we will go after finishing the presentation, we can have the discussion. So both way, I'm okay with it. So let's start the class now. And if you have any doubts, yeah, obviously you can raise your hand, or you can even tell orally also. It's fine. Okay, so many of you already heard about asymmetric synthesis, particularly those who are already studying the second year MSc. If not, then asymmetric synthesis is very interesting subject in organic chemistry. Okay, so this is the chemical reaction in which one or more elements of chirality are formed in a substrate molecule to produce unequal amounts of stereoisomeric compounds. Okay, so basically the stereoisomeric compounds will have a chiral center. So chiral center, of course, everyone will know that a carbon which contains 4 different substitutions is called chiral compounds. So in asymmetric synthesis, that you will try to have one enantiomers synthesis out of 2 which is usually exist in nature. So in other word, we can say that it is a method of preparing chemical compounds via technique that favors the creation of one stereoisomer over another isomer. So first, before going to asymmetric synthesis, you should know what is chiral compound, what is asymmetric carbon, or what is the enantiomer, what is the diastereomers. So these things you must be already studied. Okay, so based on that, that if you know those things, then very easy to understand the asymmetric synthesis. So just a simple example of this chemistry. For example, you take a acetophenone. If you take acetophenone, if you want to reduce to the corresponding alcohol, then people use any hydride agent like sodium borohydride or lithium aluminum hydride, or there are so many even palladium hydrogen. So there are so many catalysts and hydrogenation methods are available for the hydrogenation of ketones. So if you take a sodium borohydride, it's a chiral reagent. Sodium borohydride is a chiral reagent, and it can deliver the hydrogen from the both sides, from the bottom and the top of this ketone. So once it comes from the bottom, then you get the alcohol up. Once it's come from the top, then the alcohol goes down. So in general, if you take acetophenone, if you reduce with sodium borohydride, you will get 2 isomer R and S. It's a 50% and 50%. Generally, when we don't make this, thick or wedge method, wedge and dotted method, it will have simple line. So when it is having simple line, then we could understand that it is just a racemic compound. When we are writing like this, one is up, another one is down, which one is 50% R and 50% S, which means it's a racemic, 1:1. The same reaction, if you are doing a reduction with the chiral hydrogen, it's not a hydrogen, chiral hydride, H minus, then it's become very interesting that you don't get equal amount of R and S. In fact, you will get either R more amount or S more amount. In the specific example, you can see that S compound, you are getting 97.5% and the R compound, you are getting 2.5%, which means this S isomer is more and R isomer is less. So such kind of reactions are known as asymmetric synthesis or chiral synthesis or enantiomeric synthesis or diastereomeric synthesis, etc. So there are so many names for asymmetric synthesis. As I say, chiral synthesis, we can say, or stereoselective synthesis, or enantioselective synthesis, or diastereoselective synthesis. So there are so many other names also there to define the asymmetric synthesis. So any of them you can use it for defining this asymmetric chapter. So what is the difference between enantioselective synthesis or diastereoselective synthesis? Just consider the first example. So you are having one ketone, one prochiral carbon. Okay, this carbon is called a prochiral carbon. Maybe you may be already knowing. Prochiral carbon in the sense that, just a second. So prochiral carbon is the carbon in which by doing one reaction, you will be able to generate a chiral entity. So for example, ketone, if you reduce, you'll get the alcohol, which is a chiral because all the four substitutions are different. So when you're using chiral hydride, then you'll get R and S, as I saw the same example last time. So you're getting 97.5% one example and 2.5% another example. So you're having one chiral center. So this is enantioselective. When you have more than one chiral center, it's becoming a diastereoselective. For example, you are having already one chiral center exist in your molecule here, methyl, and you have another prochiral carbon over here. Okay, so this carbon, if you react with this an aldehyde, if you react the methyl lithium with aldehyde, you will get the alcohol. This is like a organometallic reaction or Grignard type reaction. So you'll get an alcohol. So this methyl group is already fixed because starting material itself is containing. There is no way that you can change. So this is the prochiral carbon which can generate two isomers. So you will get one OH down and one up, another one OH is down now. So now you can say that this is one isomer and this is another isomer. So this isomer 98%, this is 2%. So when you have more than one chiral center, we always call that is a diastereomer, and therefore this is a diastereoselective reaction. And since you are having only one chiral center, it's an enantioselective reactions basically. So this is what is given here. When you are having A plus B, you are getting a C plus D stereoisomers. Okay. So C plus D is formed in unequal amounts. So it's a stereoselective. And if the stereoselectives are C and D are diastereomers, it's called diastereoselective, and C and D are enantiomers are enantioselective. The first one is C and D are these both are enantiomers and therefore it's enantioselective. And C and D in the second case is the diastereomer and it's a diastereoselective basically. So once you understand this concept of asymmetric chemistry, then it's very easy to follow me further actually. So before that, I also would like to tell one concept of stereoselective versus stereospecific. Is anyone willing to answer me what is stereoselective, what is stereospecific? Have you ever studied these terms in organic chemistry? Anybody wanted to tell me? Okay, so stereoselective means you are having a starting material, one starting material you are having that produces two compound unequal amount. The first one you can say you take this compound and you are having a kind of two compounds it produces. One compound is more, another one compound is less. It is a stereoselective because one is selective, another one is unselective or less selective. Similarly, this also stereoselective because you are getting one compound more and another compound is less. So this is stereoselective reaction. Then what is stereospecific? Stereospecific is very interesting that your starting material itself should be a chiral compound. It should be asymmetric compound or enantiomer or diastereomer. It should be. That compound, let us consider as a A. You're converting A to B directly without having any other side products. Only one starting material will provide only one product with respect to chirality. those reactions are called stereospecific. Okay, even if you're not able to follow me very well, you just note down your notebook and try to read, and tomorrow or day after tomorrow when you have time, try to understand, because these are very important concepts in asymmetric synthesis. What is that? Stereoselectivity and stereospecificity and enantiomeric selective and diastereomeric selective. So these all the terms you must know before you go to the course. So this is another important term which is used in asymmetric synthesis called enantiomeric excess. The excess of one enantiomer over the other in a mixture of enantiomers called enantiomeric excess. This is the definition. For example, enantiomeric excess equal to percentage of major enantiomer minus percentage of minor enantiomer. I will tell you. So you are having R and S, okay, 50%, 50% in one case. Another case you are having 75%, 25%. And another case you are having 90%, 10%. Or another case you are having 99 and 1. And you are having 99.5 is to 0.5. So what is the enantiomeric excess on these cases? Okay, it's very simple. 50 is to 50. So there is no enantiomeric excess because 50 minus 50 is equal to 0. And you're having 75 is to 25, 75 minus 25, which is equivalent to 50% enantiomeric excess. So enantiomeric excess in this case, all are R. R isomer is counted as enantiomeric excess because R is always increased here. So that's why it's R is enantiomeric excess here. So similarly, you can subtract from the high value to low value to get the enantiomeric excess of any reactions over here. Okay. So how to identify that you are having an enantiomeric excess or not? So this is very interesting question. So I'm giving a compound which is a known compound structurally and chemically is known compounds, and I ask you that it is having an enantiomers. Okay, just how will you find out which enantiomer is there you are having? I also give you the authentic value of each enantiomers, or some data I will give you. So you have to compare this data. So one of the first strike comes to us is a optical rotation, because every enantiomeric compound will be able to identify whether it's enantiomerically pure or not by using optical polarimeter, okay, which is very much used important instrument. Although nowadays it's become outdated due to some reasons I will explain you later. But this is the first method developed in the science that how to identify that you are having an enantiomer or not. That is optical rotation. Because if your compound is enantiomer, if you are passing through light, then it will polarize the light in one direction. This is called textorotatory and levorotatory. Okay, so this is D or L. So we generally call textorotatory and levorotatory. For example, you take this amino acid L-alanine and D-alanine. Both are enantiomers, right? Both are enantiomers. So at the beginning, the solution just kept outside, okay? And this is normal one. And you are passing through the light. The solution is kept and the light is passing through the solution. This L-alanine will rotate this plain polarized light towards this side, okay, positive side, like this, clockwise. Okay. So now such rotation is called positive rotation and it's called plus 14. This value is plus 14. This is the rotation of this L-alanine. If you take its exact enantiomer, that is D-alanine, it will rotate opposite side. So this will counted as the minus 14. So therefore, the optical rotation of enantiomers will have equally opposite, completely opposite. Okay, if L-alanine has plus 14, then you will get minus 14 in the D-alanine. Or if you are having L-alanine have plus 19, D-alanine will have minus 19. Or if L-alanine has minus 19, then D-alanine will supposed to have plus 19. So this is very simple to understand that the optical rotations are the most important thing for the identification of enantiomers. For example, it will have completely one side rotation, only one rotation, it is 100% enantiomers. Now I can explain. So I am giving a mixer of D-alanine and L-alanine. Okay, I am giving a mixer. So one isomer I am giving 90%, another isomer I am giving 10%. Okay, so this is the mixer. So just separate it. One is a 10%, another one is a 90%. So this will rotate clockwise and this will rotate anti-clockwise. So now you just take the total amount of this one. Now you just subtract this amount from here. Total 90 minus 10 is equal to 80% of the rotation you will observe in the polarimeter. So this is how enantiomeric excess is being calculated. So if you are having 60 and 40, then 40 is anti-clockwise, is a green one, and 60 is a clockwise. Then if you subtract both, you will get the 20% maximum of one isomer, which means one isomer is 20% excess. For example, 40 and 40 and 20% is excess over the 60 here. So that is why you are observed over here. And you are taking 50 and 50, then 50% will rotate anti-clockwise and another 50% will rotate clockwise. Then it will not show any rotation in the plane polarized light. You will keep as such and you will not see any kind of change in the optical rotation. Okay, so optical rotation is the extent to which a solution of a molecule will rotate the plane polarized light as measured by polarimeter. Optical rotation depends on the concentration, path length, temperature, and the wavelength used for the experiment as well as the solvent. So optical rotation is very sensitive. Unlike it is not a robust experiment like, okay, I'm just taking a compound and I can use in any condition. So that way you cannot determine the purity of any compound basically, because this is very sophisticated method and it need completely pure solvents, known concentration, path length should be the cell in which you are going to measure. For example, you have to make a solution and use certain cell to which you will pour the solvent, then you just take the measurement and temperature. So what will happen if we change the concentration or path length, temperature? Obviously the optical rotation will also change. The specific rotation, what is the difference between specific rotation versus optical rotation? The specific rotation of a molecule is the rotation in degrees observed upon passing a polarized light through a path length of 1 decimeter. Okay, the length, which path length is a 1 decimeter here at a temperature T. So the temperature may be 20, just consider. And the specific rotation almost always reported along with the temperature. So you need to have a temperature and wavelength of light used and the solvent and the concentration. Okay, so this is the formula for the specific rotation. For a neat, which is like we are having organic molecule which is a liquid. Okay, we are not going to dilute it, we can directly measure it. Or if you don't have the liquid, it is a solid, then you have to dilute it. Then only you can pass the light. If the solid, you cannot pass the light because it won't rotate the plane polarized light. For the neat compound, it's undiluted liquid at 20 centigrade. In the formula, we can write alpha in the bracket. 20 is the temperature. Okay, D is the wavelength. And alpha is the optical rotation, which I have showed you here. Okay, this is the optical rotation. So this alpha 20D is the total unit, is called the specific rotation. I will show you in the next one. L is equal to length and the D is equal to the decimeter of this compound over here. Okay, so now, sorry, the D is equal to the density of the compound. Whether, for example, you are having a neat liquid, so this is the density. In case you are not taking a neat liquid and your compound of your organic compound is a solid, then what you have to do? You have to dissolve it some solvent. In that solvent, then you will make a concentration, specific concentration, maybe 1 molar solution or 2 molar solution or 0.1 molar solution. So at a certain temperature for a solution at 20 centigrade, for example, the formula is alpha 20D. Alpha, that is optical rotation, by length of the cell, and C is the concentration. Here D is the density of the original liquid. So this is how optical rotation versus specific rotations are used to determine the optical purity or asymmetric enantiomeric purity of the any compounds, given compounds. So usually specific rotations are written like this, that you are having previously I wrote T, so this is can be written T, or also you can write as a say D. I have written previously. You can write as a lambda also. It's a temperature, and alpha is the observed rotation, concentration gram per ml, length is a decimeter in the path, whatever the cell that you are using for determining the any solution optical rotation. Because this is the wavelength of the light employed. So usually use a sodium D light, and which usually appears at 589 nanometer basically. Okay, so if anybody have any doubts so far, please raise your hand, or maybe you can stop and ask me. Okay, fine. Consider the tartaric acid. It's a very basic organic molecule, appears in enantiomeric and diastereomeric form. Okay, so we have a compound where the both OH upside and you are having both compounds are the downside. Okay, so these both are the enantiomers. Why enantiomers? Because if you make together, it's a super impossible with the, if you keep the light over here, or glass over here, it is a super impossible both of that, and both are up and both are down. So this is enantiomers. So if you measure the specific rotation, okay, so it will give the -12. Under the same concentration, if you measure the optical rotation of RR tartaric acid, it will give the +12 at the concentration 20 and water. So this is levorotatory and this is the textorotatory. Okay. So now you consider that you mix together 1:1, SS tartaric acid 1 equivalent and RR tartaric acid 1 equivalent. Together you make a solution, and then you just send through the plane polarized light. You will never see any changes because both are 1:1, and therefore it cancels the equal rotation. For example, R rotate one side and S rotate another side. At the point of time, each compromise each other, and there will be no rotation seen in the plane polarized light. So basically, we can make a graph like this, where you are having a molar composition, like from which to which, top to bottom. Okay, and you can see the rotation in another side. So if you're at the 100% L levorotatory compound, it will be -12. Then when you're mixing with D isomer, slowly you're mixing it. At a point of time, the optical rotation will become 0, because where 50 L and 50 D is joined together. Then after you just move towards, then at a point of time you will cross that, where you will get the, after making the racemic, then one isomer will increase continuously to make 100% of the one isomer, then you will get the +12 optical value. So from these experiments, you will be able to find out the given compound is R isomer or S isomer, or whether it is a diastereomer or enantiomers. This all the information you will be able to find out by using this optical rotation. So what is the kind of relation between optical purity and enantiomeric excess? In fact, both are same. Optical purity. So in the term enantiomeric excess, or also people say EE. EE is extension for the enantiomeric excess for short. Okay, to equivalent to the optical purity, and is usually used for more often expressing the enantiomeric purity of a mixer. Okay, so enantiomeric excess is usually used to tell about the optical purity, or optical purity also known as the enantiomeric excess. So an optical pure solution containing 100% of D enantiomer and 0% L enantiomer would have an enantiomeric excess of 100. Okay, so for example, you are having one isomer 100%, another isomer 0, so equally you get the 100% of optically pure compound. So optically pure means 100% pure. And racemic mixer will have 50%, 50%. And the graph which I showed you over here, from here you will be calculate which isomer is more, basically. Just one of the simple formula or calculation that is very interesting to understand that how to calculate the optical rotation followed by the specific rotation, then followed by the enantiomeric excess. Okay, optical purity is equal to observed rotation of mixer divided by specific rotation of pure enantiomers. So, for example, you are having a mixture of enantiomer of tartaric acid that is having optical rotation +6. Okay, I am giving a solution in your hand. I ask you to record by using polarimeter. You are just recording through polarimeter. You are seeing the optical rotation is +6 degree. Okay, then you have to understand plus 6 degree, which means this is a tartaric acid D isomer. That is the dextrorotatory isomer. Why? Because dextrorotatory isomer only showed plus value previously. I showed you here. Dextrorotatory only showed plus value over here. Therefore, whatever the plus value comes, which means positive, that is a D tartaric acid is in excess. So you should take rotation, whatever the observed rotation in your measurement you got it, and the specific rotation of the compound is plus 12 degree, which I already shown you, into 100. So optical purity is equal to 50%. Then what is the molar ratio? Optical purity is a 50%, which means you are having 50% D tartaric acid and 20% D tartaric acid plus 20% L tartaric acid. Okay, this is the racemic and this is the pure. So 1:1, the 25-25, just take it together. So this is a racemic and 50% is the D tartaric. So total, if you see, you should have 75% of D tartaric acid only and 25% of the L tartaric acid. So 75 minus 25, then it comes as a 50%. So this is the molar concentration and molar composition calculation. So it is very easy to calculate the molar composition if you get the optical rotation of any compound of the given mixer. Okay. Okay, so these are the method of asymmetric, kind of determination of chirality, or maybe like identification. After doing reaction, you wanted to check whether your compound is chiral or non-chiral, or your compound is like having multiple mixtures. So this all the polarimeter will help you to some extent to understand it. Then after you will go for the kind of further changes in your molecules. Okay, so this is a little bit the basic which you have seen so far. Now let us see why asymmetric synthesis is very important. Okay, this is the most important question, that before study any course, there will be objectives for all the courses and learning objectives, kind of teaching objectives. So everything will be there. Maybe your teacher will teach you more in what to say, that more advanced way, but you understand that the nature always prefers one enantiomer. Just take any amino acids which is found in human body or animals or any type of living organism. Usually it is one isomer. Usually that is L amino acid. Natural amino acids are L amino acids, glycine, alanine. Okay, one thing. Or you take alpha hydroxy acids. Okay, like lactic acid. So this is also in one isomers. Sugars, carbohydrates, whatever the carbohydrate you see, all of them are D sugars. Okay, so these are the examples where nature itself prefers the chiral compounds. So therefore the asymmetric synthesis become very important. For example, that you are having a fly. Okay, so this fly ability to synthesize single isomers of chiral molecules, which is important since biological systems where they are intent for application are also for chiral. Different enantiomers often interact with the target biological receptors very differently and often with different responses. For example, this male flies will have one isomer and female flies will have another isomer. So this is the attractive points for this male and female flies, to understand that is the male and this is the female. Okay, so the nature, not only the nature, also the insects and other part of the living organism also will have the chirality. Maybe you must have already studied some story of thalidomide. So this is a very important drug which was introduced during 1950s, particularly in the World War II. Okay, during this German World War, that Nazis period. Okay, this was mainly given for the sickness, morning sickness. Okay, and aid to induce your sleep and kind of other small issues that you're having in your body. Particularly during the world wars, the many soldiers have not slept properly due to the fear and due to the weather condition. They were not able to sleep and they are not able to work, function well. So this drug was found in Germany and was given for all the German soldiers during that time. So after 10 years, within the 10 years of period of time, whoever the children were born, almost 10,000 kids were born with birth defects, including that they are not able to see, their eye has a problem, they're having leg has not working, and they have so many birth defects they had. Okay, so this drug was never approved by the FDA, that is the USA. And what was the reason? That you are having two enantiomers of this compound, because this is the chiral carbon over here. So you are having two enantiomer. One is R enantiomer, another one is a S enantiomer. The term R was therapeutically active. Okay, so the R enantiomer is the only sedative and hypotensive. Okay, so this is very much having the medical application. The second one, S enantiomer, is tetragenic. So this is the dangerous one. This causes all the birth defects or anything that have the bad health condition is caused by this one. So this was identified after 20 years later. Okay, after that this medicine was stopped. But the problem that when was given for the so many people in 1950s, and those people have born with a lot of health issues and all the birth defects. So from here we can understand that one isomer will have better activity, another isomer will have the bad activity. So there are so many examples. It's called caravan. Okay, so caravan is the compound. You will have the double bonds with the ketones. Okay, this is the spearmint order. It will have the very good order smell, and you will get another one caraway. This is the Persian cumin. Okay, so this is the one. So this is isomers. You don't see it together. You will see it separately. So this is aspartame. Okay, aspartame is a natural or unnatural sugar or artificial sweetener, we can say. Instead of sugar, whatever we are using, sugar which is made by the sucrose. So that sugar causes a lot of health problem. Therefore, people have made the artificial sugar. So this is aspartame. This is an amino acid. So one isomer of amino acid is sweet, and another isomer of amino acid is a bitter taste. So this is also another important aspect of difference between the two enantiomers. Not only that, there are so many examples I can give, like L-DOPA. DOPA is a dopamine. Dopamine is the drug or the organic molecule is responsible for our happiness and all the body healthy bodies. Okay, so if you have a L-DOPA, this is what we are having, which is used for the Parkinson disease, okay, treatment of Parkinson disease. Another one, D-dopamine. Okay, the D-dopamine is a toxic. So therefore, this only L-dopamine is subjected to the patients. So this is the citalopram. Okay, citalopram is an antidepressant drug. So yes, isomer of citalopram is the used for as an antidepressant one, and the R isomer shows less than 1% antidepressant effect. So Darwan is the painkiller. So +1 is giving the painkiller activity, while the -1 is used for the cough suppressant. Okay, so you can see that two isomer will have two type of applications, or sometimes it's against us also. So this is the penicillamine. Okay, this is antidote for lead, silver, and Hc, which means this is used when your body has this metal, then you can use this one to remove the metal poison, because this is like a ligand, it just catches over here. So this R isomer is used for that purpose, while the S isomer will cause the blindness. So this is an example of eye drops, where S isomer used as eye drops, where R isomer do not show any effectiveness in the eye drops. The most common thing is ibuprofen. Okay, this is the painkiller in which only one isomer is active, that is S isomer. So R isomer is not active, only one isomer. But most of the time when we are buying in the shop, they are not giving S isomer or R isomer together, they are giving, because this R isomer do not have any side effect. That is how they are mixing and giving together. Otherwise they have to separate the two isomer and they have to give, which is very expensive basically. Okay, fine. So now we have seen further what is the real importance in the chemistry perspective. Why chemist has to work on the asymmetric synthesis, and we have seen that the effect of different isomers for the different applications, or one is more application, another one is the bad applications. So something like that. Okay, now we will see what are the different approaches are available in asymmetric synthesis. So how one can achieve asymmetric synthesis? So this is the approach. So usually these following five approach were seen. One is chiral resolution of your racemic mixer. Okay, this is the first approach was found in early years. The next one is a chiral pole synthesis. I will tell you what is chiral pole synthesis. Another one is a chiral auxiliary synthesis. Okay, these are the three methods were widely used, and these two are the latest things. Latest means last maybe 15 years people have started using chiral reagents mediated synthesis and chiral catalyst mediated synthesis. So if you know what is the difference between chiral reagent and chiral catalyst, then you can easily understand. Or even if you know the difference between reagent and catalyst, then it's very easy to understand. Reagents are used one equivalent based on the substrate. The catalysts are used very less amount when compared with the substrate's molality. Okay, for example, if you're taking 1 mole of substrate, then catalyst you'll use 0.1 mole approximately, something like that. So this is the difference between. So let's see the resolution of enantiomers. Okay, so what is the resolution of enantiomer? Which means you are going to separate the racemic mixer into two enantiomeric forms. You are having R plus S together, and you are going to separate R separately and S separately. You are going to isolate it separately. But what is the problem in enantiomers? You may be knowing already. Enantiomers are chiral, but it will have identical physical and chemical properties. Okay, it will have identical and chemical properties. Only one thing will change, what enantiomeric like optical activity. Here also it won't change too much. It will change just opposite. You are having one isomer is plus 5,9, and another enantiomer will have minus 5,9. This is the only change. Otherwise, your boiling point will be same. Your dipole moment will be changed. Dielectric constant will be changed. Your melting point will be same. So all of them will be same. So therefore, another thing that it will have a different biological properties, but how does it matter for isolating the enantiomer? Depends on the biological activity, we cannot isolate it. Basically, we need to find a method to separate the two enantiomers from the racemic mixer. Okay. So what are the routes to resolution? Resolution means separation. What are the methods for separate the these enantiomers from racemic mixer? One is spontaneous resolution. Another one is a chromatographic method. These all are physical method. Physical method means that it do not need any other chemical reactions or something like that. Whatever you are having, directly use some method and separate it. Another one is a chemical method. Another one, this is diastereomeric compound formation and kinetic resolution. Second one. And third one is the biochemical methods. Okay. Third one is the biochemical methods. So let us see one by one. Spontaneous resolution. Okay, spontaneous resolution means you are having a racemic mixer in a beaker, and after some time that racemic mixer slowly evaporates and get crystallized in two form. Okay, for example, if you take a sodium ammonium tartrate, this is a salt, dissolve it in a water and crystallize it. It will form two type of crystals. Okay, both are mirror image of each other. Okay, mirror image of each other, exactly like kind of our hand. One crystal will look like this, another crystal will look like that. Okay, so those such type of chemicals, such type of crystals can be taken by our hand itself by using a kind of glass. We will be able to use some kind of pincer type of thing, then you can separate by hand itself. This is a physical method of spontaneous resolution. This was first told by the Louis Pasteur. Okay, he's a great scientist known to be a chemist and also microbiologist. and he has developed kind of method of pasteurization. That is a cleaning before for any biological substance present in the milk and anything. That is what he first identified, and vaccination against anthrax he is found over here. So he is the Louis Pasteur. He is the scientist who is the father of asymmetric synthesis, we can say. Although his name was not mainly told, but he is the first person who identified the chiral compounds that exist. So the Pasteur was able to separate an R and S isomer of tartaric acid with tweezer, okay, and the microscope due to the difference in structure of the respective isomers. Okay, he was using this tweezer, means that pincer, and using a microscope, like he was able to see the crystals by eyes, naked eyes, that he was able to separate it. So Pasteur actually separated the plus isomer of sodium ammonium tartrate, which exists left and right handed crystals. This type of difference is extremely rare, therefore is not a general method. For example, such kind of crystallization and isolation from the hand is not very common, because not all the compounds are solid, and even if it is a solid, doesn't matter that it will become a crystal or not, that we do not know. So one of the very famous scientists, Girl Geisen, told, he is from Princeton University, that Pasteur was doubly lucky, not only because few compounds consist of enantiomer which form crystals which are different, but also because of the temperature of the air in Pasteur's lab that day was just happened to be the right temperature for the final step in the preparation of the crystals. What he mentioned that the Pasteur is really lucky, and his lab temperature allows the crystal to form in two way, because if you change the temperature, the crystallization is not going to take place. And he was having a kind of microscope through which he was lucky to see that there is a two type, and he was able to identify. And his lab conditions, kind of accepts the formation of crystals. So he told. So the Pasteur's discovery led to the birth of stereochemistry. That is the first intimation on the racemic to chiral, which means there is a compound which can be called as a chiral. Previously, people never think about the chirality. That was 1948. Okay. So then after that, won the first Nobel Prize in chemistry, 1901, and Joseph actually Lelbil. So he got the late 19 independently for the asymmetric compounds. They got the Nobel Prize, of course, that they have extended the studies to demonstrate there is a carbon which is the four different atoms are attached is called chiral compounds. They have just declared this one to the scientific community, and they both won the Nobel Prize. So the crystallization and isolation by using a hand is a difficult process, because not all the compounds are going to help you or going to make the thing. So therefore, another method has come out. This may be after 10 years later. 10 years later, it came another method, that is the chromatography. So many of you must be already studied about chromatography, or some of you may be already doing the chromatographic separations in your laboratory. So chromatic separation relies on the difference in affinity, that is organic molecule, between stationary phase and mobile phase, which means chromatography will have the two phase system. One is a stationary phase, which is usually a solid. Another one is the mobile phase, which is usually liquid, for column chromatography. Okay. The stationary phase, if the stationary phase made with normal like silica gel, is a very commonly used stationary phase for the column chromatography, and if the achiral one, then there is no way that you can separate it. If you are able to make the chiral silica gel, then you will be able to separate the compound. Maybe you can understand this one. This is the achiral stationary phase, silica. So this is commonly widely used for the isolating your mixture of compounds. Okay, not the same, not the enantiomers. It is just for the any compounds that is having a mixture of the one, but not the enantiomeric, not the chiral one. So this is achiral stationary phase. If you attach this achiral stationary phase with any of the chiral inducing substrate where it has the chiral excess, for example, this compound is only one chiral center it is having, and this is only one isomer. Or you can make this kind of substrates where you are having two chiral carbon, but completely pure compound. Okay, if you attach with the silica, then this become chiral stationary phase. Okay, it's chiral stationary phase. If you isolate compound by using this method, enantiomers, you will not get any separation, because this is also a chiral and your compound also mixture of enantiomers. But if you take this one, this is enantiomers, pure enantiomers, and your compound is a mixture of enantiomers, and therefore it will be able to separate it. For example, like this. This is a drug Valium. Valium is used as antidepressant. Okay, it is having R and S isomers, and this carbon you are having chiral center. So in industry, they were able to separate. Sorry. In industry, they were able to separate these two compounds by using a chiral column. So consider this is the chiral column where you have chiral stationary phase, and R and X is a mixer. Just you are adding into the column, just eluting with some solvents, okay, like ethyl acetate or hexane, you're eluting it, and slowly this compound will come, in which one isomer will have interaction with this chiral stationary phase, okay, one isomer, and another isomer will have less interaction with this one. Let's say R is having less interaction and S is having more interaction. So when S is having more interaction, it will come slowly because it is interacting, it is attaching with that. And R do not interact much, and slowly it comes. At a point of time, R will completely comes out. You should separate it. Then after you will get the S isomer later on. So this is the column chromatography separation. Okay, this is the physical methods. Whatever we have seen, crystallization followed by a column chromatography is the physical method. Next one is the chemical method. It's the diastereomeric salt formation. Okay, so this is one of the very commonly used method in asymmetric synthesis. So you know that one enantiomers will have same chemical properties, but biological properties will be different. Except optical rotation, all of them are same. But diastereomers are not like that. Diastereomers will have different boiling point, different melting point, different density, refractive index, solubility. Okay, it can be, for example, one isomer can be a solid, another isomer can be a liquid. It can have the melting point different. Okay, so these are very important about the difference between diastereomers and the enantiomers. So enantiomers cannot be separated with achiral stationary phase. Okay, enantiomers. Understand this one. But diastereomers can be separated by achiral stationary phase, because these compounds will have different RF value. That is the TLC. How many of you know TLC? I do not know, but TLC is called thin layer chromatography. This is the most widely used to see whether your reactions are been completed or still ongoing, or you're having side products, all the things you will have over here. Okay, so therefore the most important thing that if you're having a diastereomer is very easy, but you wanted to make an enantiomer separation, then what you will do, you take an enantiomers, consider you're having an enantiomeric mixer, R acid and plus S acid, 1:1 you're having. Okay, but you use a base which is a chiral base, it is a S isomer. If you mix together, R and S will become one salt, and S and S will become one salt. So here it is enantiomer. When you mix with the acid, it's become a diastereomer, because here you are having only one chiral center, but you are having another chiral center here. When you're mixing here, you will get the two chiral center. Therefore, it becomes diastereomers. Now we can separate by column chromatography, or you can do distillation, because it will have different melting points and boiling points. And you separated RS salt separately and SS salt separately, which can be done by using column chromatography, distillation, or recrystallization. You will be able to get it. Once you did RS salt separately and SS salt separately, use the acidification reagent to separate out the R acid, which you need as a full enantiomer, and whatever the base that you have used, you can recover back. Similarly, from S and S salt, you will be able to get the S acid completely and S base completely. Okay, so one of the best example for this one, you just take a lactic acid, racemic lactic acid you are having. Okay, R and S 1:1. Okay, R 50%, R 50%, yes. So you take a phenylethylamine. Okay, phenylethylamine is a chiral compound. It is having only one isomer. That is why it's R1 phenylethylamine. So you just react together. You will get one salt. That is RR salt. You will get another salt, SR salt. SR salt. Okay. So previously it's our enantiomers, and this is also enantiomer. When you mix two enantiomer together, you're getting diastereomers. Now this can be either isolated by column chromatography, or you can distill it, or you can recrystallize it. Once you separate this after isolation of this one, then you just acidify. You'll get the lactic acid, pure lactic acid of R isomer and pure lactic of S isomer from this compound. And your starting material, which is used for the diastereomeric formation, can be isolated and reused for the further separation. So, which means most of the companies does the synthesis of chiral organic molecules using such diastereomeric method separation, because it is very less expensive. So this is another example. So naproxen is another painkiller type of drug, which is widely used in medical clinically. And you take a glucosamine. This is the glucosamine. Okay, glucosamine is a naturally occurring D sugar, and it's a chiral compound. All the sugars are chiral. So this is the chirality exists in this carbon. And mix with naproxen, you're having acid over here and you're having amine here. So this is a base and this is the acid. So you will get a stable solid and a crystalline solid salt. So now this will be different type of salt and this type of salt, and you can isolate it and filter it, and after that you can use either acid or a base to make your naproxen S isomer and R isomer separately. This is another example of esterification. Okay, so here what you have seen difference here, these all are ionic bonds. Okay, these are ionic bonds. You're having acid base interaction. These all are ionic bonds, which means it's not very stable. Okay, but you're making covalent bond, that is esterification. Here you're making direct bond itself. So you're having the racemic alcohol. This alcohol is the racemic, but you're having enantiomeric pure acid. Just do the acidification to make the ester. Now this chiral center is fixed already, therefore it won't change at any point of time. But this chiral center is not known. You have 1:1 both. So obviously you will have this all, that you will get this one, and which is equivalent to two compounds. It can be down, this is down, or this can be up, and this is down, because this is fixed. Now it is a diastereomer, can be separated by column chromatography, and by using the sodium hydroxide, esterification can be removed, means ester can be hydrolysis to get your starting material recovered, and plus R alcohol and S alcohol can be easily separated. Okay. So this is the another example where this is also one of the compound called kind of a drug. It is also widely used for the kind of used as a starting material to synthesize various drug molecules. So they have done some reactions, organic reactions, to make the chiral center over here. Then after they are making an esterification with menthol. Menthol is a chiral compound, will have one isomer, and this is a racemic. And when you mix together diastereomer compound A and diastereomer compound B, both will form. And one compound will have the melting point 103 to 104, and another diastereomeric compound will have 72 to 73.5. Okay, so here itself you can separate it very easily. You can separate it by crystallization method. Then after you can hydrolysis to get your pure enantiomer of this racemic amino acids. You can get the pure enantiomers. Then after that, whatever you want to do, you can do further reactions. It doesn't matter with asymmetric synthesis after that. So now I ask that if you take both are racemic, for example, your alcohol also a racemic, and your acid also a racemic, then also it is going to form a diastereomer. Why can't we separate? Because this mixture will have 4 compounds basically, not the 2 compound. In diastereomer normal, these cases you will get only 2 compounds, but here you will get the 4 compounds. For example, both plus minus, like this, both can be down or both can be up. For example, one can down, one can be up. So each will have two compounds. When you take these two and hydrolysis, you are going to get again the starting material both. So therefore, most important thing to separate the enantiomers, you should have the partner compound which you are going to use for separation. That compound should be enantiomerically 100% pure. Then only you will be able to separate the enantiomers from the mixer resolution you can do. So now this is very interesting to know that you see this 1R, 2R, 1S, 2S, these both are enantiomers. 1S, 2, 1R, 2S and 1S, 2R, these both are enantiomers. Okay, just 1 second. Yeah, so the relationship between these two are the diastereomers and the relations between these two are the enantiomers. Okay, so this is very important to know, kind of understand the structures of the compounds. So next one is the kinetic resolution. Okay, next one is the kinetic resolution, how you will be able to synthesize chiral compound by using kinetic resolution. Kinetic resolution itself, we can understand the depends on the reaction rate. Okay, so each enantiomer will have some reactivity. One enantiomer will have high reactivity and another isomer will have the low reactivity. Based on the reactivity rate, you can separate the reactions. For example, you are having starting material R and you are having starting material S. Okay, R is equal to R isomer, S is equal to S isomer. You are doing some reaction. Let us say you are converting the starting material to the product R. So if you are using a chiral catalyst or chiral reagent, the only R will convert to product R. I mean SMR will convert to PR, but the SMS will remain as such. Then at this level, you will be able to separate that SMS, that is one isomer of the one which is unreactive, another one is the product one. So this is called the kinetic resolution. And as opposed to kinetic resolution, kinetic resolution does not rely on the different physical properties of diastereomeric products, but rather on the different chemical properties of the racemic starting material, which means chemical property, not the physical property. Chemical property means reactivity. For example, some compound reacts very faster, some isomer reacts very faster because it approaches in different way, and another isomer reacts with the less. So based on this, and if you are able to separate the compound, it's called kinetic resolution. Kinetic resolution by synthetic means was first reported by the Markwold and Magazine in the 1899 in the esterification of racemic mandelic acid. Okay, so this is what they did. For example, they have taken the excess of mandelic acid and reacted with menthol, and it is forming the one ester is forming more and another ester is forming the some amount is less. So one isomer you will be able to isolate by using saponification, that is hydrolysis. Another one you will not be able to isolate it. Just a second, I am getting
Excuse me, sir. Sorry for the disturbance. Your voice is not audible. Please check your mic whether it is in unmute or not. Am I audible, sir?
Okay, sorry, I did not see.
Yeah, now it is audible. Yes, please.
Yeah. Okay, so the biological resolution was the last one I have told. Unfortunately, I forgot to switch on the mic. So there is
Yes,
a
sir. From
biological.
here you can talk, sir. Thank you.
Yeah. The biological substance which can also act as a kind of reagent to take only one isomer, and another isomer will be survived, and one isomer will be eaten by the biological organism like microorganism, bacteria, or fungi, or maybe yeast or anything. Okay, for example, Louis Pasteur took the racemic ammonium tartrate and mixed it with the penicillium, which is a kind of fungi that compound, that biological substance eat only one isomer, that is a D ammonium tartrate, and leaves the L ammonium tartrate unreactive. Which means that if you take a mixer and one ammonium, like L ammonium tartrate, you can easily separate from the mixer by using biological substance. Or similarly, like 1890, Emily Fisher is also a very famous chemist, scientist, worked on many area of chemistry, particularly in sugar. Like he only designated the structure of Fisher projection, that you can see the structure of Fisher projection was by the Emil Fisher. So he has taken the hexose sugar. There is a hexose sugar means a 6 carbon containing sugar, and treated with yeast. So this sugar exists in two types, D sugar and L sugar. So this yeast ate only the D hexose and left without touching the L hexose. So somebody wanted to prepare the L hexose. Obviously, he just take this yeast and mix with the mixture of D and L containing hexose, and after a few days he will be able to get the L hexose pure 100%. Okay, so this is one. So what is the advantage and disadvantage of chiral resolution methods? Are usually it's scalable because you are not using anything extra over here, and also cheap, particularly like tartaric acid and all is cheap. This type of synthesis was proceeded in 1950 to 70s. Then slowly the people move to another approach, that is I have a few more slides later. And the disadvantage that in the limited scope, not all the compounds can be done the same method, and you need to do multiple crystallization. Another important thing, if you're having a mixture of enantiomer, you want to separate it. Let us say you're having R and the S 1:1. Then you are separating R isomer 50%, which you need, and the S isomer another 50% is unused, is going to be wasted. And this is the another disadvantage of this method over here. Okay. So after coming back to this all, then people have gone for the next level, that is the synthesis, laboratory synthesis, starting from the scratch, that you start small starting material, from where you build your chirality. Okay, this is another method. So this obviously will take at least another 1 class or 2 classes for me to complete the whole asymmetric synthesis portion. I wish to stop at this point, and maybe in future, if I have a chance to have one more class, or maybe 2 more classes, I will just continue, and maybe after a few days. Okay, and if you have any doubts, then I wanted to give some time to discussion now. If anybody have interest, please you can rise, or you can talk to me now.
Sir, we have received several questions in a charting box of YouTube as well as Zoom link. So
Okay.
after finishing this talk, I guess it's better
you can ask now, because I will not be able to complete other things because I have so many other things to say. Yeah, you can ask.
Yes, sir. First of all, I would like to thank for your excellent talk, sir. Few questions we have received. This question asked by Gulshat Begum. What is the difference between stereo center and chiral center?
See, stereo center is a common, common name is used for all enantiomer and diastereomers, all the things. Okay, the chiral center is specifically that the we say it's a carbon in which there is a 4 different groups are attached over here. In fact, there is no 100% difference. We can say maybe very minimum. The general term is stereo center, and the chiral center is a very commonly used term basically. So there is no much difference I can speculatively say on this. Yeah. Yeah. Next
Thank you,
question.
sir.
Yeah.
Yeah, thank you, sir. And the same person asked one more question.
Mm.
Why do only chiral molecules rotate light?
Yeah, because the compounds which is having 4 different groups will have different dipole moment and different type of rotations automatically. So this is a physical property of any organic compounds will have some kind of activity. So in this way, it was identified that it can rotate the plane polarized light just by the attraction, like kind of interaction between the light and other things.
Thank you,
Yeah.
sir. And this question asked by KBS Sabari.
Yeah.
What is the meaning of optically active compound?
So optically active compound meaning that your compound having a chiral center or asymmetric compound, asymmetric carbon with full enantiomeric, like not full, at least you are having enantiomeric excess. Optically active means enantiomeric excess is available in your solution. Given compound is having the optical activity, which means that you are having enantiomeric excess in your compound.
Okay, sir. And this question asked by Santi.
Okay.
Non-chiral compounds also showing optical properties. Am I correct, sir? Then what is the reason?
Okay, so we cannot say non-chiral compounds can show optical activity. Those compounds may not be having the stereo center, but it will have the different arrangements of organic molecules. Aggregation, one type of aggregation and another type of aggregation. That molecules sit on another, one molecule on another in different opposite may. Then those time it can also show some rotations. Yeah.
Okay, sir. And using microorganisms,
Yeah.
can we able to separate the racemic mixture?
Yes, actually, whatever I shown you, these 2 example like Emily Fisher and Louis Pasteur, they have used the racemic only, and you cannot separate both the mixer. Okay, you're having R plus S. Either you can separate R or you can separate S. Depends on the microorganism that you're going to choose.
And again, the same question, same person asked. What about the efficiency if we are using the same?
If you're using the efficiency.
Yeah, microorganisms, we can
Okay, what
able
is
to
the
separate
efficiency?
the
It's
racemic. Yes, yes.
100% efficiency, 100% efficiency, because enzymes or bacteria or yeast are very selective for any reactions. So its efficiency is very high.
Okay, sir. And this question asked by Christina Jensi from Stella Maris College.
Okay.
What will the effect on specific rotation if we measure the value in 2 different solvents?
Yeah, so this is the difference on the solvent which you are using, and this is the difference on the temperature and also the path length through which cell you are going to measure your solution. So we cannot tell, for example, you are having 1 molar concentration, it may have the plus 18, and here is the same compound you are going to measure with the 2 molar solution, it is not going to be 36. Okay, it can vary, but only thing it will have is the positive value. If it starts with the positive, it will always have the positive till concentration increases over here. But there is no direct kind of proportional or there is no direct proportional connections between this molar concentration. It can vary at any extent.
Thank you, sir. And the same person asked one more question. Can
Yeah.
chirality affect isotopes composition?
No, basically, yes, if you are having a racemic mixer, if you are going to do the isotopic experiment on the mixer, obviously one isomer may be getting more isotopic insertion, while other isomer will have less. Because the reactivity is different based on the reaction which you are going to do, basically.
Okay, sir. Then Lavanya from Rajeshwari Vedachalam Government Arts College, Engalpattu. That student asked about the optical purity and enantiomeric excess. Both are same or not, sir?
It is both are same. Both are same.
Okay, sir. And this question asked by Yashwadhar, NIT Sikkim. What is the reason that the same compound with a different optical conformation become toxic, like in case of
yeah, so the enantiomers can
thalidomide?
react.
Yes.
Yeah, so the enantiomers can react in general, if you take in our body that all the cells which contains DNA, RNA, or any biological substance are chiral. So if you're having an enantiomer will have the R and S. So R enantiomer may bind with some biological substance in one direction. The S enantiomer no need to bind the same way because R and S both are different in the biological system. So it is going to make a difference in the binding sites itself. For example, an R isomer binds with place where it's supposed to be binding, and S isomer binds to the wrong place, which causes the kind of side effects. In which that is what happened in the First World War, Second World War, that morning sickness medicine happened. So that is the reason.
Okay, sir. This question, Zainab Begum, Madras
Yeah.
Christian College. How can we tell if a mixture
Hello.
tell the mixture is racemic or not? Yes, sir.
Yeah.
Am I audible, sir?
Yeah, audible. Yeah, audible. Yeah. So the
Can I repeat the
mixture
question, sir?
Yeah, I understood the question. Just a
Okay,
second.
thanks.
Yeah, how to say the given compound is enantiomers or the enantiomerically pure or racemic, right? So yeah, that is why you need to have authentic. For example, before going to measure the optical rotation, if you wanted to check whether your given solution is enantiomerically pure or it is having the complete racemic, that before authentic, what to call, before that somebody must have done that experiment and they should have reported in scientific journal that this compound should have plus 20 or plus 18 optical rotation, or maybe minus 18, minus 17 optical rotation should have. If they did not report about this, you are going to do the first time, then there are so many other methods first to do, then after we should report it. That is the first report. So that cannot be identified unless we have the reported method. But racemic one, you can easily identify your compound is racemic or not racemic. You can easily see by using the polarimeter. You measure the optical rotation, it will not show any rotation either on the right side or left side. It will not show. So from that you can come conclusion that is a racemic. But if it is rotating one side, you cannot find out whether it is R isomer or S isomer.
Okay, sir. And this question, Riba Koshi, does specific rotation change with solvent?
Yes, obviously it changes. For example, if you are measuring in methanol or if you are measuring in dichloromethane, it will change. If you are measuring in water, it will change. So it will not have the same value in the optical rotation. It will have completely different values.
Okay, sir. And this question asked by Bessie. Does asymmetric synthesis is possible for optically active compounds without chiral center?
See, optically active compound itself is asymmetric compounds. Okay, you are having asymmetric center already in your molecule, which is enantiomerically pure or diastereomically pure. Then whenever you are doing next reaction, it will going to provide mixer. So that is the next teaching in the, like I have a lot of other teachings to go through, then maybe this question will not come. But basically, if you are having a chiral center which is enantiomerically pure, you are going to the next step in which you will get one isomer more or another one isomer less. That time you will be able to isolate through column chromatography and you should go for further step synthesis. So by blindly it's not possible, but you should realize that you have to make a diastereomer, then only you can go for the asymmetric synthesis.
Thank you, sir. And this question, Pavan Kalyan. Sir, can we able to calculate the enantiomeric excess using any equation? If yes, please kindly explain.
Yeah, so enantiomeric excess is very simply you can calculate by using the how much amount of major isomer minus how much amount of minor isomer, then it is equal to the enantiomeric excess. So there are so many other things also there. Maybe he can look into the just in Google to type how to calculate enantiomeric excess. There are so many formulas are already given in the Google, so you can check.
Okay, sir. And this question asked by Preeta from Yatiraj College. Sir, in what way the sulfur form of S form of thalidomide is related to the birth defect? Can R form alone be isolated and taken, and it will be avoided again for the birth defect?
Yeah, it is been done. It is being done that that mixer or racemic mixer was isolated and R isomer only is now given for everybody. The S isomer is completely stopped. So that is already being done. It is not that they are giving mixture of this one. And yes, isomer, why it caused birth defect, I do not know exact reason why it caused, but I have a feeling that it binds to some other place where it can make defects in your body.
Thank you, sir. And this question asked by Janaki, then RV Government College, Sengalpattu. How to determine the stereochemical relationship between any molecule?
A stereochemical relationship, first of all, you should know at least one compound, what is the configuration of that compound. Then relative configuration based on the reaction, some reactions you will be able to do the things. So it is not possible blindly at the first step itself. First of all, we should do small experiment to determine the first chiral center, whether it is R or S. Then after we have to do the further reactions. To stepwise we have to build the configuration. Otherwise, it's not possible.
Thank you, sir. Thanks a lot for your valuable talk, sir, as well as answering for all the questions. Definitely, I will call you again for one more session, sir, because the talk was very interesting. And we have received several feedback from our students. All are requesting us to hear one more talk from you, sir. So kindly accept our invitation well in advance. So definitely, I will find the suitable time during this session. I mean, in this summer, 1 month summer internship, I will call you one more time.
Maybe we'll find another alternative week next
Sure.
week or sometime. So I will let you know. Also, you can contact me. So I will able to
Sure,
complete this asymmetric synthesis to the students. So it will be, I will, after that, I will share my slides. So everyone can take the slides, and obviously they will be able to spend their own way. And also they can contact me by email or by phone. There's no problem.
Sure. Thanks a lot for.
Thank you, sir. Thank you so much. Yeah. Thank you, sir.
Next session, sir. If you want to say anything to the participants, please, sir.
Yeah, I wish that everyone should learn. This is the time which is very bad in whole history of world, and we must be safe and try to understand more chemistry, because nowadays there are so many online coaching centers or online teaching videos are available. So no need to suffer. Even if your teacher was not able to complete the syllabus or something, you'll, if you are so interested to learn, then there are so many opportunities are there, online videos. There is a government, the Indian government itself has opened some center for the online teaching, and also you can look into this one. So hopefully we'll meet in the next class, sir.
Thank you so much, sir. Now I request Nivedita to deliver a vote of thanks.
It's my great honor to propose the vote of thanks today. On behalf of the management of B.S. Abdurrahman Crescent Institute of Science and Technology and everyone, I extend my immense gratitude to our chief guest, Professor Dr. Jaikumar Kandaswamy. Thank you so much, sir, for accepting our invitation and spared your immeasurable time to grace the session. Sir, you have delivered a very valuable presentation on asymmetric synthesis. You started with the stereoselective and stereospecific basis. Followed by that, you detailedly explained the aspects of stereochemistry, shared the story of thalidomide in World War II. You illuminate our minds by explaining synthesis of various kinds of organic compounds along with its separation ways. Kinetic resolution and biochemical resolution were also aspects of your presentation. You patiently answered all the questions of the participants. Today, we had an opportunity to hear your lecture, sir. Your presentation showed your years of research and your depth of understanding chemistry. We all are fortunate enough, sir. Thank you so much, sir, for being here with us today. I also like to thank.
Yeah.
Yes, sir. I also like to thank the conveners of the program, Professor Dr. S. Kuttirani, Dean, School of Physical and Chemical Sciences, Dr. D. Ishwaramurthy, Head of the Department of Chemistry, for the constant support and motivation. Heartfelt thanks goes to a beloved professor, Dr. N. Vasimalai, for being the backbone of the summer internship program. I finally thank all the participants for their active presence. I once again express my sincere gratitude to our chief guest. Thank you all.
Yeah, thank you so much, and see you soon next class. Bye, sir. Bye to all of you.
Thank you so much, sir. Thank you, sir. Now we can move for the next session. Anna University Department of Chemistry students, Madhupriya, she's going to give a seminar now. Madhupriya, are you ready?
Yes, sir, sure, sir.
Please share your screen.
Yes, sir. Is my screen visible, sir?
Yes, please put in full screen mode.
Okay, sir. Shall I start, sir?
Yes, go ahead. Yes, speak little loudly.
Thank you. Okay, sir, sure, sir. Great good evening to all present here. So this is P. Madhupriya from Applied Chemistry, Anna University. So here I'm going to share my knowledge and idea through this seminar by grasping this opportunity to everyone, not as the seminar like in Google. So here I'm going with an hydroxyl functionalization of boron nitride nanotubes and DFT studies for using in targeted drug delivery. So under the supervisor of Dr. A. Pandurangan sir, Department of Chemistry in Anna University. So outline of the project is that aim and scope of the work, introduction and nanotechnology, boron nitride nanotubes in nanotechnology, and functionalization of boron nitride nanotubes in biomedical applications, and functionalization of BNNT and simulation studies and results and discussions, conclusions and future scope of my work. So the aim and scope of the work is that drug delivery is one of the most important application in nanotechnology, and in particularly the targeted delivery of anti-cancer drugs using nanotubes. So at most, generally we are using the cancer for a cancer treatment. We are using the cancer drugs. We are taking the cancer drugs directly in the sense, just like cisplatin drugs. If we are taking in the sense, it just affects the cancer cells as well as the normal cells, normal tissues also. So to avoid the normal damage of the cells, we are coming up with a nano carrier. If it affects the normal cells in the sense, it just kills the lung failure. We are coming up with lung failure, kidney failure, everything and all. So we planned to divide a nano carrier to cancer tissues. So we planned a nano carrier which carries the chemotherapeutic drugs like cisplatin drugs to the cancer tissues. So proper understanding of encapsulation of the drug molecules inside the nanocarriers is vital for the development of nanoscale drug delivery. So we choose a nanocarrier as a BNNT because it's in high purity and the high quality of the BNNTs have been confirmed to be inherently, it's a non-cytotoxic to health and the environment due to their chemical inertness and structural stability. So it's generally a biocompatible thing. So only we are choosing a BNNT without inducing the oxidative DNA damages and apoptosis. So a proper understanding of encapsulation only we are doing it BNNT with cisplatin. So in the present study, molecular dynamics, which is a computational study, were utilized to investigate the encapsulation of anti-cancer drugs inside the boron nitride nanotubes. So according to the results of the encapsulation study, we can able to tell the drug was compatible with the BNNT and preferred to locate inside the nanotubes. So we are using this enhanced drug delivery systems. It is possible to target the cancer cells directly without affecting any of the normal cells. So introduction part, the size of the nanometer is just about 1/1,000,000th of a meter. So about the nanotechnology, it has achieved the status of one of the critical research endeavors in this 21st century. So at 1959 itself, Finman developed nanoscale machines, and the term nanotechnology coined in 1974 themselves. So to date, nanoparticles have been used for cosmetics and drug delivery, and it has been recently that nanotubes have gained significant attention and all. So boron nitride nanotubes is a structurally similar thing, and comparative with the carbon nanotubes, it is a hexagonal network, and it is an electrical insulator with a band gap of about 5.5 electron volt. So what's the functionalization of BNNTs in biomedical application is that it's a polymorph of an boron nitride have recently attracted a huge attention as a drug carrier. Not only it's attracting as a drug carrier, we are using as a nano carrier to deliver the biologically active cargo into the living systems for cancer treatment. So it's in low bioavailability, limited effectiveness, and the requirement of re-administrations and lack of selectivity. So the nanoparticle drug delivery systems such as like BNNTs and CNNTs may offer several advantages over typical dosage forms, which include the production of the drug from rapid diffusions and sustained drug delivery and enhanced drug concentrations in the target sites, and also improved the efficiency and reduced the undesirable side effects we are using the BNNT as a carrier in the sense. So how the functionalization taking place in the BNNT in the sense, we are taking a hydrogen peroxide with the BNNT. This is the protocol for functionalization of BNNT. We are choosing a 5 nanometer BNNT and a 50 to 100 nanometer BNNTs for a comparison manner. So we are with the BNNT and hydrogen peroxide, we kept in a magnetic state for 24 hours and heated at 120 degrees Celsius for 24 hours in an autoclave. After that, then filtered out and dried at 80 degrees Celsius. So this is the images shown which we used in our lab for a functionalization of BNNTs. Thus, the hydroxylation of BNNTs via chemical reactions between the BNNTs with the hydrogen peroxide that had been sealed in an autoclave, where hydrogen peroxide was dissociated to generate an OH radicals and reacted with the BNNTs at 120 degrees Celsius. So the OH groups were chemically bonded to boron sites in the final product. We had verified by the IR spectroscopies, everything and all. So first one is that 5 nanometer BNNT and functionalized BNNT, and second is that OH BNNT of 50 to 100 nanometer. So the scheme of the reaction designed in this work for the BNNT chemical functionalization, this is the scheme of the project. So when the BNNTs are used as a precursor, various methods become available to prepare the OH boron nitrate derivatives, including a plasma treatment and hydrothermal reactions with the sodium hydroxide and sodium hydroxide assistant ball milling method, and the reactions with water at a high temperature, or using the agents that can generate the OH radicals, etc. Now, by using these various methods, we can develop then hydrogen peroxide. We can develop in functionalized BNNTs. So when we look into results and discussion, SEM images can show that how the nanotube is looking like before the functionalization and after the functionalization. We can just confirming that how the nanotube is looking like and all. For 5 nanometer and 50 nanometer, and EDAX just confirms that how much oxygen content, how much functionalization has been taken place in the functionalized 5 nanometer BNNT and 50 to 100 nanometer. So in 5 nanometer, the functionalization takes place a little higher, like 72.14 atomic percentage, and for 50 to 100 nanometer, it's little lower only in 9.64 percentages. So FTIR spectrum confirms that 5 nanometer functionalized BNNT shows then strong OH stretching in 3200 centimeter inverse, and for 50 to 100 nanometer, it's a big bang in 3040 centimeter inverse. So simulation studies, we can come across with an encapsulation to do the encapsulation, how the to know how the interaction between the cisplatin and the BNNT has been taken place. So the predicted electronic and structural properties of BNNT compared to CNNT towards the platinum cancer drugs recommended that BNNT can act as a drug delivery vehicles. So the encapsulation of the drug inside the nanotubes is more favorable than the adsorption of drug outside the nanotubes. So this study, that computational study, helps to study the encapsulations and the releasing process of the cisplatin as an anti-cancer drug. And DFT studies, we can confirm that both molecules were located inside the nanotubes. So all theoretical results have shown that the therapeutic agent complex, which is that cisplatin drugs, was not affected when it was attached to the BNNTs. So this is, I'm just giving the gist of what we have done. Like we have done an material studio, this images with cisplatin, BNNT with cisplatin, and we can come up with an optimal convergence of optimal energy convergence graph. Using this these things, we can confirm that how the BNNT and cisplatin has been encapsulated and it's not affected and all. So conclusions, the covalent functionalization method was adapted to enhance the hydrophilic properties of 50 nanometer and 5 nanometer, which increased the aqueous solubility of the BNNTs. So FTR confirms the presence of an hydroxyl functional groups, and SEM shows that micelles anchored on the surface of the BNNTs are responsible for the dispersion of the BNNTs in water. So while using the computational studies, which is DFT calculations and MD simulations, we can confirm that no entrance barrier when the molecule tends to encapsulate, and also BNNTs appear to be a good nanocarrier to transport the cisplatin to the cancerous tissues. So for the future scope of my work is that results obtained on this study has thrown some light on the safe biomedical applications of OH functionalized BNNTs for the cancer treatment, and also in vitro studies, including cytotoxicity studies and in vivo studies, could definitely extend the application of functionalized BNNTs as a targeted delivery agents in cancer therapeutics. So these are the reference I used here. Thank you, sir, and thank you, Dr. Wasimali, sir, for this for giving this better opportunity. And I'm encouraging everyone to resume their knowledges and their everything using these opportunities and all. Thank you, sir.
Thank you, Madhupriya, for your nice talk. Am I audible?
Yes, sir.
Okay. Now we can move for the question session. Admin, give
Yes,
an
sir.
option to the Zoom link people, unmute by themselves. So those who are in a Zoom link, you are allowed to talk with Madhupriya. So you can ask your queries. Okay, I have few questions. So you
Yes,
just
sir.
chosen cisplatin. Am I correct?
Yes, sir. Platinum drugs.
So there are many drugs available these days. Taxorubicin,
Yes, sir.
many drugs.
Carboplatin. Yes, sir.
Yeah. Why did you choose this cisplatin? Is there any specification?
No, sir. We are just targeting the first cancer treating drugs. That is a cisplatin, which is an heartbeat for the metal-based compound. So we just choosing the cisplatin, sir. And also its interactions will be better while we are using the literature reviews. We come up with and interactions between the B and T has been better in cisplatin, so that we are come up with that cisplatin, sir.
Do you know about the cost of cisplatin? Cost.
No, sir. I don't know about that.
Okay, the cancer drugs are very expensive,
Yes,
but
sir.
for research
Only.
purpose, laboratory grade people are using.
Okay.
Okay, so because of the less time availability, so I can close the seminar session. Thanks, Madhupriya, for your excellent talk and convey my
Thank
records
you,
to
sir.
your supervisor. Uh,
Thank you so much, sir.
now, so already we fixed the deadline for assignment submission and also the project mini review, mini project, home mini project, many things. We totally understood the problem. The people have a video, but it is 20 MB, 30 MB. The meanwhile, there is no standard format we have given for the report writing. But check now your WhatsApp message. There we have posted for the report writing. For example, name, participants ID, and institute name should be in the top left corner. Then title of the project proposal, I mean the project report. Then next introduction, what you need to write in the introduction, how many paragraphs limit, that things also we have posted there. Then next one, experimental procedure. So you have to write in a past tense, and it will be if you have seen. Then after that, results are observations. So what did you observe from your experiment? And in this experimental details or in observations, you have to write the details about what way your work superior than others, what way your work differ from others. Like that, you have to highlight it. Then the last point, usefulness to the society. So from your projects, so whether this society going to gain something or what way this project useful to the society, that is you can write in a bullet point or you can write one paragraph. That's all. So we have given this standard procedure. So I know well you are all busy, so I can extend 1 or 2 days for the submission. There is no issue. So the deadline of the home mini project submissions further I extend to 20th. This is the final extensions. Furthermore, we cannot able to do it. So 20th of July is the deadline for the submission of home mini project and its report. So please be ready. And some exceptional case, we have received some messages like affected by COVID-19 and some accident, something. So that person's personally contact me, chat me, then we will consider your case as a special case. But all others you should submit on time. It is my request. And one more things we just kept in our mind. If all of you sending 20 MB, 30 MB documents, then our storage of the drive, it will be full. So therefore we have a 1500 participants. It is very hard to store all of your documents. That is why we have decided to ask you to create the uh, drive link. So using that drive link, we can able to see. You have to give the access for us to see your documents. That one we already sent in a video. Now I request Abhilash, my students. So Abhilash will explain how to do the drive link. For example, so you have a video in your mobile phone. In that video, you have to send to us, but we are not accepting the video as such. We are asking to create the Google Drive link. That link you have to send to us. And also we created Google form. In that Google form, you have to give the details about your name, RRN, and also the file documents of home mini project, the report. That one you can upload. I guess one GP or something we have given, one MP. So you can check that one. After that, there is one column. In that column, we are asking to send the Google Drive link, so that video, it will be stored in your file. We can able to see with your phone, and it is also confidential. You don't need to worry about this. For us, it is a document. And there is one question I know about that question. For example, the students already, sir, already I sent to you what I have to do now. Already I sent to your given email ID. Can we able to send one more time? Yes, please. So please send me one more time. Those who are already sent, please do it one more time, so that it will be recorded. So that verify those who are submitted, those who are not submitted, then what we have to do for them, or whether we can able to give the certificate for them or not. These things we can able to do it. So that is why those who are already submitted, thanks a lot for your submission. But meanwhile, it is my small request, please do it one more time. Now I request my students Abhilash, so he will tell you how to create the Google Drive link. Then he will teach you how to paste in a form and how to give the access for us to see the videos. Abhilash,
Yes, sir.
are you ready?
Yes, sir. Yes, sir.
So Abhilash will do that work.
Okay. Hello all. Many of you have some doubts about uploading a video in the Google Drive. Wait, I will show how to do it. My screen is visible.
Yes, yes. Yes, sir.
Yes,
Vilas.
Abhilash, visible.
Visible.
So just open a Google Drive and right click on your mouse. So it shows a new folder, upload files, upload folder, etc. You have to create one new folder for your project. Give a name your project. I'm giving a name like a mini project. Okay. So my folder get created. You can upload a folder. Just see, you can upload a folder or also a file. If you upload a file, it may cause some errors. So it is advisory to create one new folder in the Google Drive. Okay. So after creating a folder, just open it. So the folder got open. In your folder, just right click on it and click the upload files. So select your file which you want to upload. I have created one dummy document like example. You can select multiple files also. So my file is get uploaded. So click on that your name of a folder. So it shows many icons like this. So click share. So it shows like this. And if we want to see your files and your folder, just change it to anyone with the link. Click that. Okay, so it's changed to restricted mode to the anyone with the link mode, and change to the change here viewer, commentator, editor. It advisory to select the commenter or editor. If you select a viewer, we can view a folder only. We can't so you can select commenter or editor. I select editor and copy the link here and click done. So the form link will send will already send to your WhatsApp group, open it and fill all the fields. In the home mini project video format, the Google Drive link, just paste the link that you copied, fill all the fields and click submit. It's a simple one. In for the mobile users, I already uploaded one video in the WhatsApp. I'm sharing the screen in my laptop. I can't show how to do it in the mobile. So please view that video. You can know how to do that.
Thanks,
Sir?
Abhilash. Dear participants, we are doing this much level. So therefore, wait a second. So we already uploaded the videos. That one, those who are using mobile, so you can get the information from there. And this video, it is also available in our YouTube. So whenever you get a doubt, so you can just recall through these videos. So kindly help us. So this is the best way to see your videos as well as your documents. And then we created Google form. So then we can easily identify those who are submitted, those who are not yet submitted that details. And still people are having some problem, one or two cases. They are saying that they didn't get the ID, participant ID and other details. So that people, if you are not getting the participant ID, don't view the certificate. If you have any doubt, you can ask me. So admin, please check in a Zoom link as well as YouTube link starting box. If they have any questions, please read it. Then I will answer for that question. Abhilash, is there any question in YouTube chatting box? Admin, anybody?
Sir, am I audible, sir?
Zoom link chatting box. Yes, audible.
Sir, in the YouTube, Ashish Kumar asked, sir, we will not make a video during the preparation of mini project. How can I do? How can I upload that, sir?
So
Asked
if
by
you are
Ashish
not
Kumar.
prepare the video, then it is not good. Again, I'm saying. So there is a more chance without doing the work, you can able to write the report. For example, if someone want to prepare the nanoparticles from banana leaves, they can take a photographs from internet and then put inside. They can write by their own. But the only evidence video. So try to make a video one more time because you already done. Consider that one as your rehearsal. So do one more time. Explanation. We cannot encourage that type of things. So video is mandatory. Please do it one more time. That is the best way. Any other question, Abhilash?
So many people's asking again.
Abhilash, am I audible? Can you hear me, Abhilash?
Hello, sir.
Yes, please repeat again.
Many people's asking again where I can upload my assignment.
So it means that they are not listening anything. So simply they switch on the video, then they left from the place. So we cannot able to answer for that type of people. So please listen the entire talk, the answer we have given. So check the Google form. In that Google form, you have to upload the Word file or PDF file. The whatever you have to write it, that details also we give given in a Another one PDF file. As I mentioned earlier, the introduction, experimental part, then results or observation, then final usefulness to the society. So you have to follow that one. And also I extended the deadline. It is to 20th. So this much details we given. If they are not listening things, we can't do anything. Please move for the next question, Abhilash.
Sir, if that is possible, I can explain again, sir.
They are asking you to explain one more time.
No, sir. I am telling.
Sorry.
I am telling, sir.
So you want to explain one more time clearly,
Yes, sir.
correct?
So many people have doubts, sir. So only.
Okay. So dear participants, when you are seeing this video, please enlarge the screen, your mobile phone screen. Then you can able to see where his cursor is there, where he is clicking. So I can request my students to do one more time. So he will do
So
it
still many
carefully.
people.
Abhilash, please do it.
Yes, sir. So still many people have having doubts. So I can explain again. You took video for 100 MB about that, but in the Gmail you can send up to 25 MB. So you can upload your video in your Google Drive and create a link of it and paste it in the given Google form. So I can give a demo how to create a link and uploading files and documents. So just open your Google Drive and right click on your mouse. So wait 1 second. Right click on your mouse. It shows a new folder, upload files, upload folder, etc. You can upload your files always a folder, but uploading a folder it may cause some errors. So it advisory to create one new folder in your Google Drive. Click new folder and give the name of your folder. I am giving the mini project as a name and click create. So my folders get created. Just open it by double click on it. So your folders get opened and in your folder just right click on it and the same icons are will show here. Click upload files. So select the respective file which you want to upload. I have created one document, example document, and select it and click open. You can select multiple files simultaneously and click open. So my files get uploaded. Just click the down arrow mark next to the name. So it shows many icons. Click share in it. Wait 1 sec, sorry. So click share. Change to the restricted mode to the anyone with the link mode. When you submit the Google Drive link in the restricted mode, we can't see your files. So change it to the anyone with the link mode and change to the viewer to the commenter or editor. It advisory to select the commenter or editor mode. Okay, I click editor and copy the link here. There is one icon, copy link. So my link is copied and click done. So open the Google form and there is many fields like email, participant name. Fill all the fields in the Google Drive link field. Click that and just paste it. And so fill all the fields and click submit. Okay. For mobile users, I am again repeating that there is one video is shared in your WhatsApp group. Please view that. I already explained there how can you upload and create a link and paste it in the Google form. Please view that.
Thanks, Abhilash. So this video also will be there in our our Crescent summer internship video. So you can check one more time. So all the videos are available, whichever we link, we send to you the YouTube link. So click that one. Then previous day, from the beginning to today, whichever event we have conducted, all the videos are available in a YouTube. But if you are seeing late night, midnight, we don't worry about that one. But those who are really attending this one, their people have to get the certificate. If you are saying that I am not having time, so not able to see or not able to come on time, we cannot consider. Those who are submitting the feedback form, that things only we are considering. Okay. So with this end, thank you so much for your kind attentions. The feedback link will be posted in a chatting box of YouTube as well as Zoom link. So it will be active for 30 minutes. All are requested to fill it. Tomorrow, Saturday, day after tomorrow, Sunday, we don't have any event. So Monday 19th only we have a event. But please check your WhatsApp message frequently. We have a plan to conduct a quiz on 20th. 20th time will let you know. We have a plan to conduct after 6, after finishing of this event, or before 3. So give your comments in our chatting box of WhatsApp. So it will be encouraging us after seeing that comments. Many people given very good comments. Thank you so much for your encouragement as well as nice words about our program. So still I'm waiting for few more comments from the people. So in each groups, I request all the people to send your comments. So if you want to write paragraph or 2 paragraph, 3 paragraph, please write and send through our email. That one also we will be keeping as a record. So definitely this feedback we will be forwarding to the higher authority. You know very well how much effort we are taking. So today talk, hope you all enjoyed well. So organic chemistry. So definitely based on your request, I will call again Professor Jayakumar Kandasamy during this summer internship. So he will give the further details about the asymmetric synthesis. Thank you so much. See you by Monday. Tomorrow, day after tomorrow, we don't have a class. Utilize this time to prepare for the home mini project. Don't waste your time. 20th is the deadline. 20th is the Tuesday. 5 p.m. is the deadline. 20th, 5 p.m. So all of you requested to submit your home mini project on time. Further queries or further doubt, if you have it, please feel free to contact us. But before so without seeing that documents whichever I sent to you, without seeing this video, don't ask any question. Whatever you want to ask the question, and the answer is there in this video, and we already sent the documents. So please go through it. Further you have doubt, please feel free to contact us. Don't contact us without seeing these documents. Thank you so much for your fullest support. Admin, please post the feedback link to the both YouTube as well as Zoom chatting box. After a few minutes, please close the session. See you by Monday. Thank you.
Thank you, sir.